Hello, AP Pre-Calculus. This is Mrs. Leong, and I will be teaching 14.2, Day 2. All right, so we're still talking about limits. And just a reminder, different ways that we can find limits when x approaches a number is we can look at the graph and we can visually see where that limit is approaching. We can plug in that number into the function, and if it comes out with the limit, it comes out with the limit. If it doesn't, like if it's 0 over 0, you can factor and simplify it. Or, especially if it goes to positive or negative infinity, a table is really useful to see, and just kind of plugging in points close to that value of x, or yeah, that value of that number, plugging it in and seeing kind of where that graph is approaching. All right, so we're going to use limits to find now the rate of change, or the slope, at a certain point. All right, so we're going to use limits to find this rate of change at a point. So, for example, if I want to say this function is x squared, all right, and I want to find the rate of change between 2 and 3, okay? Just remember, average rate of change, it's like the change of y over the change of x. So here, what that would look like, it would be the function at 3 minus the function at 2 over 3 minus 2, okay? And this is my average rate of change that I'm looking for. All right, since f of x is just x squared, when I plug in 3, I get 9. Plug in 2, I get 4. And then when I simplify this, I get 5. All right, so then that's my average rate of change between 2 and 3. Okay. For b, between 2 and any number. All right, so I'm just going to say that's x. So if I have my average rate of change, f of x minus f of 2 all over x minus 2 would be my average rate of change. And plugging that into my function x squared, that's going to get me x squared minus 4 all over x minus 2. All right, and you can even factor that part using difference of perfect square and divide that, and that would get you just x plus 2. Okay, there you go. Okay, so for C, where it says at 2, this is where we now use our limit, all right? So to figure out where the limit of that rate of change is going as x approaches 2, all right, I'm basically trying to figure out what this is as x approaches 2, right? Which we simplified to be x plus 2. So plugging it in, I get 4. All right. So that's how we can use limits to get that number. Okay, so go ahead and try it for example 2. And then once you have your answer, unpause the video, and then you can check and see what you got. All right, so if you're ready with the answer for the next problem, go ahead and take a look. This is what I got. All right. So I used my average rate of change formula, plugged it in, factored using my difference of perfect cubes, and that reduced out the x minus 2, and then that left me with x squared plus 2x plus 4, and then applying the limit as x approaches 2, plugging it in, I get a final answer of 12. All right. Now incorporating some trig limits here. All right, so these are some trig limits you want to know. All right, and so the limit of sine of x over x as x goes to 0 is equal to 1. All right, and I think we saw that in a previous lesson. And this one right here, that one, cosine of x minus 1 divided by x as x approaches 0, that's going to be equal to 0. All right. And then this one, the limit of sine of 2x over x, the limit approaching 0, that is going to approach the number 2. All right. And I think some problems in the textbook demonstrates that. So if you want to look into that a little bit deeper, I think there's some problems in the textbook that you saw in the lesson. All right, that's it for lesson 2. Day 2, go ahead and work on that homework, that worksheet, and good luck.